Let's go through some examples of making our confidence intervals. So the process that we're going to go through is, first step, we're going to check the conditions. So we're going to go through those pieces of the central limit theorem and make sure we pass all the conditions so we can use a bell-shaped curve. Then our next piece will be to construct the interval. So with that, we'll use our formula. So taking our sample proportion plus or minus critical z-score times the square root of p hat times q hat over n. And then our last step is to make a conclusion. Now we have to go through all of these steps. We can't leave anything out. We have to check conditions because it's proof that we can even do this. We have to show our work for constructing the interval, and then we need a full sentence answer to really tie together what we found and making our claim about what's occurring in the population. All right, so we have a poll that asked 166 adults in the US whether they were baseball fans, and 46% said that they were. So we have a sample size of 166, and from that sample we got this sample proportion out of 0.46. Now, just to bring in something that we talked about with sampling distribution of proportions, and I want to emphasize it here as well. Sometimes these problems give you the proportion in the percentage form. So with that, you just change p hat to 0.46. What they could have done with this is given you the count. And what I mean by this is that they could have phrased it, and it's not exact here. In fact, we get a little strange value, but what they could have said is they surveyed 166 adults and 76 said that they were baseball fans, meaning they give you the count out of the sample size of how many people said blah, 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 blah. So with that, just know that sometimes you have to make the proportion by taking whatever the count is divided by the sample size. Just when we get to this calculation of the confidence interval, the value that's going in there for p hat, it should always be representative of a percentage, or basically you should be having a decimal between 0 and 1 there. It's just when they give you the count form of it, you have this extra step of making the fraction, and then you can get to that decimal. If they just give you the percentage, then you just copy the decimal form of the percentage. All right, so we're going to construct a 99% confidence interval. So with 99% confidence, I'm just going to go ahead and grab the critical z-score that we found in the last video, which was 2.5758. And with that, we pretty much have all of our pieces. The only extra piece I might do is go ahead and grab q hat, which is 1 minus 0.46, which is a 0.54. All right, so what we want to do is make an interval and for the true proportion of US adults that are baseball fans. So where we have the sample and we can see from the sample how many are baseball fans, we want to state something in terms of all US adults. So first step is to check the central limit theorem. We're going to check conditions first. So first piece is independence. Again, I just want to see that you thought about these. So independence, randomization, you can essentially just copy those down and check them. Independence, we're talking to 166 adults out of all US adults. So we're looking at definitely less than 10% of our population. So we have independence. Hopefully these 166 adults they chose were random US adults. They don't say that specifically, but we'll assume we're all good there. Then the piece that we'll show work for is the success-failure condition. So taking 166 times 0.46 and 166 times 0.54. So that'll be 76 and 90, which is more than or equal to 10, so we also pass the success failure. So that'll be our first step of work to show that basically it lets us use the z-score because we have a normal curve. All right, our next step is to construct the interval. So now I'll be plugging into the formula, And actually, I'll copy the formula down here just so that we can see it side by side. You don't need to do this each time, but just since this is the first example, we're really doing start to finish with this. All right, our sample proportion is 0.46 plus or minus 2.5758, and then square root 0.46 times 0.54 over our sample size of 166. And like I said in the first video, what I like to do for simplification is find our margin of error, so plugging in everything on this right-hand side. So let's say I jump over to Desmos's scientific calculator, or whatever scientific calculator you're using. I'll have that 2.5758. I'll just format it like I wrote it, so the square root, and I'll have a fraction of 0.46 times 0.54 over 166. So 0.0996 there. And then we'll split into the two calculations because I want to find my lower bound and upper bound. So lower bound will come from the subtraction of those two numbers. So we could go back to the calculator and subtract them, which would be a 0.3604. And then for the other side, we want to add those two numbers, which would be a 0.5596. And that's constructing our interval. We end up with our lower bound and upper bound. So then our last step is to write our conclusion. So we want to include our confidence level, the range of values that we found in that second step, and then wording for our population proportion, which is actually given to us up above there. So what I'll say is with 99% confidence, the true proportion of US adults that are baseball fans is between 36.04% and 55.96%. So with that, we have a certain level of confidence, which in this case is we're really confident in this conclusion here. And then we can talk about for all US adults, the proportion that are baseball fans is going to be between 36% and about 56%. All right, so that's what a confidence interval question should look like start to finish, showing these steps and showing your work. In the second step here, I probably showed more work than I'd really expect. In fact, in this next example, I'll show you kind of what I expect since you'll be mostly in the calculator, and then a full sentence answer, including our three pieces. All right, let's do with the same data, but what we're going to do is switch over to 80% confidence, and then we'll talk about how the confidence level changes the interval. So, critical z-score of 1.2816. And we're going to go through our three steps. In fact, I kind of like the structure of dividing it like this. So first step is to check the conditions, checking our central limit theorem. And actually with this, since our data didn't change, I'm not going to copy it all again. It's just the same. It's the same setup, same proportion, same sample size. So nothing changed there. What did change is this construct the interval stage. So our sample proportion's the same, plus or minus, but what changes our critical z-score. So now we'll have 1.2816 and then square root 0.46 times 0.54 over our sample size of 166. So in terms of showing your work, I do want to see this stage of plugging in the values. And then this next stage of going to the calculator and finding that margin of error. So if we plug everything in, that should be a 0.0496. And then here's where I showed some extra steps, but you could jump to Subtracting those two, you should get a 0.4104. Adding the two values together should be a 0.5096. So with that, I could write a similar sentence up above, but what's going to change is my confidence level and the interval. So with 80% confidence, the proportion of US adults that are baseball fans is between 41.04% and 50.96%. All right, so let's compare these. In terms of the the proportions that came out, so with 99% confidence, we got this range of 36% to 56%. And with the 80% confidence interval, it was about 41% to 51%. So we could see is the interval for the 80% confidence is much smaller. It has this range of about 10%, whereas the 99% confidence interval has a range of about 20% between the two. So let's talk about what this means. So the confidence levels relating to how sure we are that the true population proportions in that interval. In terms of creating our sampling distribution, we're choosing this z-score value to kind of select how many samples would be in that range. And with this 1.2816, we're getting 80% of the samples. Whereas with 2.5758, we're including more samples, so we're 99% confident. So in terms of confidence here, and answering these questions in terms of certainty versus precision. So what happens to the size of the confidence interval the more certain you are? So as we increase our confidence, which is like us going from 80% to the 90%, what we can see is that we get a wider range of values. There are more values included in that interval. So the interval itself is larger, or you could say it's wider. Whereas if we decrease our confidence, if we lower the confidence level, this interval is going to be smaller. And how I like to think of this is like going fishing with a net, because what we are trying to do is we're trying to capture this population proportion. So if I'm going fishing and I want to be 99% sure I'm capturing a fish, I want to use a big net. If I could just choose a net to help me accomplish that, then I want to choose the biggest net that I can, so that if I'm 99% sure, then I have this wide net to capture everything. So that's what we're doing here, is we're ending up with this really large interval because we want a wide net to capture that true population proportion. Whereas when I decrease my confidence, if I switch to, say, I go fishing and I say I'm 80% confident, or let's even bring it way down for an exaggerated example of, say I'm going fishing and I'm like 10% confident I'm going to catch a fish, maybe I would just take one of those little aquarium things, like my confidence is so low in it, I could just take the teeniest, tiniest little net and just kind of splash in the water and not really try all that hard. Because the confidence is so low, if we're not being confident that we're capturing it, then we can use this teeny tiny range, because it's not okay, but it's basically okay that true population proportion's landing outside of that range. So with lower confidence, we end up using a small net because we're less confident of that true value being inside. So that's how confidence level can influence the width of the interval. And it's something that researchers can think about too, because say they want this 99% confidence. They want to make this statement. 99% confidence is amazing because you're so sure in your solution. But with that comes a wider interval. So with that's less exact. In terms of another exaggerated example, it's like, I'm 99% sure that your proportion is between 1% and 99%. Creating this really big interval, sure, you'll have really high confidence with it, but then the interval itself doesn't say anything. So what can happen is Maybe they want to have high confidence, but this interval is just too wide. It's not saying anything specific. So then maybe they'd bump down the confidence. Maybe they'd go to 95% or 90%. And then at that stage, if it's still not showing great results and still too wide of a range, then they should start playing with sample size. And actually, in your participation for this module, you'll see the influence of sample size in an example in there. But there are these ways to play with, like making a beneficial statement at the end of it and playing around with the confidence level you're using and even the sample size that you're using.